Very good morning, students. In today's class, you are going to learn about the properties of DFT, starting with circular folding property. So, what is circular folding? So, if you have your sequence x of n, whose DFT you can write it as capital X of k. Then, if you are going to take a sequence which is a folded one with respect to capital N value given, can represent it as x of minus n with capital N. So if the sequence is folded and if I am going to find the DFT of the folded sequence, it must be equal to x of minus k with circular shift n. That is, if the sequence is folded, then even the DFT is also a folded one. That is what we are going to prove here. So in order to prove, I'll start with the known DFT definition x of k equal to summation n is equal to 0 to n minus 1 x of n wn power of kn, whereas k ranges from 0, 1, 2, 3 up to n minus 1. So here I am going to replace m with n minus n. That is, I am going to introduce a index m which is taken as capital N minus n. So from this we can write what is small n. So small n is equal to n minus m. So wherever small n is there, I am going to replace with n minus m. So x of k is equal to summation. Since the index starts with n is equal to 0, I need to change the index to m. So put n is equal to 0, will be getting m is equal to n. And for the upper limit, put n is equal to n minus 1 in the equation, will be getting as m is equal to 1. So hence, we can write the summation as from m is equal to n to 1, x of, instead of m, it is capital N minus m into wn power of k into, instead of n, again it is n minus m. And we are going to change the limit of the summation. As we know, the summation is from m is equal to n to 1. I can interchange the limit as 0 to n minus 1. Why? Because we know the periodicity property of x of n. It is going to be periodic for every time period n. Hence, the limit can be changed as m is equal to 0 to n minus 1 x of n minus m wn power of k into n minus m. And in simple way, you can say the sequence from 1 to n, it is equal to 0 to n minus 1 also. Hence, we have replaced the index m is equal to n to 1 as 0 to n minus 1. And here m is a dummy variable what we have introduced for simplification purpose. Hence, it can be replaced by small n. So, x of k is equal to n is equal to 0 to n minus 1 x of n minus small n wn power of k into n minus n. So, in the next step, wn I am going to segregate as two terms as wn power of kn into wn power of minus kn. And here you can observe the value of wn power of kn is 1, which I am going to substitute in the next step. So as I told, wn power of kn is equal to 1, which is replaced here. So I am getting x of k is equal to summation 0 to n minus 1 x of n minus n wn power of minus kn. So in the next step, instead of k, I am going to put as n minus k in the entire expression. So x of k, it is replaced with x of n minus k, which is equal to summation n is equal to 0 to n minus 1 x of n minus n wn power of minus n into, instead of k, we are going to put as n minus k. And then I am going to separate this wn as two terms and then I am going to simplify. As we know, wn power of minus n into n is 1. So finally, on the right hand side, we are getting the equation as summation n is equal to 0 to n minus 1 x of n minus n wn power of kn. And if I interchange the left hand side and the right hand side terms, I am getting as dft of x of n minus n is equal to capital X of n minus k. So which is nothing but the simple definition for the dft of x of k, and dft of x of k is nothing but the dft of x of n. Hence instead of x of n we have x of n minus n here. Hence, I can write as the dft of x of n minus n is equal to x of n minus k. Or you can write the same expression x of n minus n as x of minus n with circular shift n. Similarly, on the other side, for the frequency domain expression, x of n minus k can be written as x of minus k with circular shift n. Both are same. Hence, we have proved the circular folding property of DFT. Let us see the next property of DFT, that is multiplication in time, or otherwise it is also known as modulation property of DFT. So what this property says, that is the multiplication in time, that is I am going to multiply two different sequences x1 of n and x2 of n. If the multiplied sequences, if I am going to take the DFT, it is equal to the circular convolution in frequency domain multiplied by 1 by n. That is DFT of x1 of n into x2 of n is equal to 1 by n x1 of k circular convolute x2 of k. So this is the statement for multiplication in time property. So how we are going to prove it? So in order to prove, I am going to start with the left hand side. The DFT of x1 of n into x2 of n is equal to, it is nothing but based on the definition of DFT I have written here. So it is summation 0 to n minus 1. Instead of x of n sequence, we are going to replace with x1 of n into x2 of n into Wn power of kn. And it is named as equation 1. So in the next step, x2 of n. What is x2 of n? You can write the expression for x2 of n in terms of IDFT equation. So x2 of n can be written as 1 by n summation n is equal to 0 to n minus 1 x2 of n Wn power of minus l into n. That is, this is nothing but the IDFT expression of x2 of n sequence, and name it as equation 2. So this equation 2 I am going to replace it equation 1 and I am going to substitute there, and we are going to simplify. So put equation 2 in equation 1, we get DFT of x1 of n into x2 of n is equal to 1 by n summation. So what is x2 of n? That is L is equal to 0 to n minus 1 x2 of n into Wn power of minus ln, which is multiplied with Wn power of kn. Again, I am just interchanging the summations and I am going to write it as 1 by n summation. The L summation I am going to write it first. So it is summation L is equal to 0 to n minus 1. Along with that, the L term is x2 of L. So x2 of L is taken outside. So the remaining, it is summation n is equal to 0 to n minus 1 x1 of n multiplied with Wn power of kn into Wn power of minus ln. As such, the remaining terms we are writing, just we are exchanging the summation terms and we have written here. So later I am going to combine Wn as a single term. So Wn power of kn into Wn power of minus ln can be combined, and it can be written as Wn power of n into k minus l. And later if you see, it is the last term, it is the expression for the DFT, whereas instead of k, it is k minus l. So it is 1 by n summation L is equal to 0 to n minus 1 x2 of l into x1 of k minus l with circular shift n it is. So left hand side already we have the DFT of x1 of n into x2 of n is equal to 1 by n summation L is equal to 0 to n minus 1 x2 of L into x1 of k minus L with circular shift L. And if you observe this entire expression, it is leaving this 1 by n, it is the expression for the circular convolution. That is, it is nothing but the convolution sum formula. So we can replace this by taking simply the convolution between x1 of k and x2 of k. Hence finally you can write it as 1 by n x1 of k circular convolute x2 of k. So hence we are proving here the DFT of x1 of n into x2 of n is equal to 1 by n x1 of k circular convolute x2 of k. Hence it is proved here. Okay. Thank you. Let us continue in the next class.